air, and analyze chemical information at a level we can barely imagine. When these animals encounter a sleeping human, they are receiving a flood of olfactory data. And a lot of that data is just wrong. You smell wrong. You smell like synthetic fabrics like nylon and polyester and whatever chemicals were used in the manufacturing process. You smell like processed food, the meal you ate hours ago, the snacks in your bag. You smell like soap and shampoo and sunscreen and insect repellent, a cocktail of artificial compounds that has no analog anywhere in the natural world. Beneath all of that, underneath the layers of modern human life, you smell like a primate. Which is something, but it's not the thing. Not the deer or the wildebeest or the rabbit that these predators have evolved over millions of years to recognize and hunt. A predator's hunting instinct is not generic. It's not a vague desire to kill things that moves. It's a finely tuned system calibrated to specific prey. A wolf's predatory response is triggered by the movement patterns of ungulates. A lion's strike mechanism is activated by the shape and speed and smell of animals it has hunted thousands of times. You don't fit the pattern. You're not in the system. You're an anomaly. And anomalies trigger caution rather than aggression in most predators. There's also the Campfire Effect, which is one of the most underrated things humans have ever figured out. Fire is one of the only stimuli that produces a near-universal fear response across virtually all land animals. It's not a learned behavior. It's not something animals figure out from experience. It's innate. It's ancient. Animals that were afraid of fire in the wild survived wildfires by running. Animals that weren't afraid of fire didn't. The fear is so deeply embedded that laboratory-raised animals who have never been near fire in their lives will show avoidance behavior at the smell of smoke. It goes that deep into the evolutionary code. Humans discovered fire somewhere between 1 and 2 million years ago. And for most of that time, sleeping next to a fire has been standard operating procedure. We weren't doing it just for warmth or to cook. We were doing it maybe without knowing it consciously. Because it works as a repellent. A campfire doesn't just keep you warm, it broadcasts a signal into the surrounding dark that says something dangerous is here, something that controls fire, something that should be avoided. The predators got that message, and they've been getting it for so long that the message doesn't even need to be decoded anymore. It just triggers avoidance automatically. You figured that out before you figured out farming, before you figured out pottery or writing or architecture. Fire first. Smart move, honestly. Now let's tackle the biggest myth about predators, because movies have spent decades getting this completely wrong. Predators are not reckless. This is so important. The image of the apex predator as this fearless, unstoppable killing machine that attacks anything within range is fiction. Pure fiction. In reality, large predators are extraordinarily careful about what they engage with because they have to be. A lion doesn't have health insurance. A wolf doesn't have sick days. One serious injury, a broken leg, a deep bite wound, a damaged eye, can mean a slow death by starvation. In the wild, injuries don't heal at the vet. They either heal on their own while the animal somehow still has to eat and hunt, or they don't heal and the animal dies. This means every single decision a predator makes about whether to engage with something is a survival calculation. Is the caloric value of this target worth the risk of injury? Is this prey item familiar enough that I know how it will behave? Is the chance of a successful hunt high enough to justify the energy expenditure? A sleeping human fails this calculation in multiple ways. First, unfamiliarity. A predator is most confident attacking prey it knows. It's watched the prey animal hundreds of times. It knows how a zebra runs, where its blind spots are, how it kicks when it panics. It does not know how a human will respond. Humans are wildly unpredictable. We might wake up screaming. We might have tools nearby. We might have other humans nearby who will respond. We might thrash in completely unexpected ways. For a predator trying to minimize risk, that level of uncertainty is a massive red flag. Second, the size question. Humans, when they stand up, are actually pretty big. We're tall, upright, and our bipedal posture, standing on 2 legs, makes us appear larger and more imposing than most prey animals of equivalent weight. Researchers studying predator-prey dynamics have noted that bipedalism is itself a kind of threat display. Standing upright is what gorillas do when they want to intimidate. It's what bears do when they want to look threatening. A creature that walks around like that all the time as its default mode reads as inherently assertive to other animals. Even asleep, the silhouette of a human shape is unusual in a way that doesn't say easy meal. Third, and maybe most importantly, why bother? There are almost always easier options. A predator with a healthy territory and a functional ecosystem has access to prey it knows. Prey it's comfortable hunting, prey that fits its biological template. Going after something strange, unknown, and potentially dangerous when there's a perfectly available impala or rabbit in the vicinity makes no sense from a survival standpoint. The risk-reward math just doesn't work out. Here's something else that almost never comes up in these conversations. Your sleep is not as deep as you think. This is actually one of the more astonishing things about human biology. We experience sleep in cycles. You go down into deep, slow-wave sleep, then you come back up into lighter stages, including REM sleep, where your brain is actually quite active. And during those lighter stages, researchers have found that your brain remains surprisingly responsive to the environment around you. External sounds still get processed. Unfamiliar noises are more likely to break through into awareness than familiar ones. Scientists call this the sentinel function of sleep. The idea is that even while resting, animals, including humans, maintain a